Have you ever wondered why ancient civilizations often settled near groundwater sources rather than solely relying on rainfall? Today, let's dive into the fascinating comparison between groundwater and rainwater and understand their roles in human civilization. Let's start with something we're all familiar with: rainwater. It's nature's purest form of water when it first falls from the clouds, like a fresh, clean slate. But here's where it gets interesting. As rain falls through our modern atmosphere, it becomes nature's environmental diary, picking up traces of our industrial footprint. Those pristine droplets can collect pollutants like sulfur dioxide and nitrogen oxides, sometimes becoming what we know as acid rain. Now, imagine rainwater as a naive traveler, easily influenced by its surroundings. When we collect it from our roofs or other surfaces, it picks up whatever it encounters: bird droppings, leaves, dust, you name it. It's like a sponge, absorbing stories from every surface it touches. But groundwater? That's nature's filtered water, and it's fascinating how it works. Think of groundwater as rainwater that's gone through Earth's ultimate purification system. As it slowly seeps through layers of soil and rock, it gets naturally filtered, removing most biological contaminants. It's like having a giant natural water treatment plant beneath our feet. However, groundwater isn't without its quirks. During its underground journey, it picks up minerals from the rocks it passes through. In some areas, it becomes what we call hard water, rich in calcium and magnesium. While these minerals can be beneficial for our health, sometimes groundwater can pick up less desirable elements like arsenic or excessive fluoride. This brings us to an interesting point about mineral content. Rainwater is like distilled water, pure, but lacking minerals. It's soft water, missing those essential minerals our bodies need. Groundwater, on the other hand, is nature's mineral water, enriched by its long journey through Earth's geological layers, especially in areas with limestone deposits. One crucial aspect often overlooked is how these water sources are replenished. Rainwater is the ultimate source, feeding both surface water and groundwater systems. It's like nature's water cycle starting point, determining how much water will be available both above and below ground. Understanding these differences helps us appreciate why our ancestors often preferred groundwater sources. They might not have understood the science, but they recognized the reliability and generally better quality of groundwater for sustaining their civilizations. Even today, this knowledge continues to shape our water management strategies and urban planning decisions. Rainwater and groundwater differ in several important ways regarding purity, mineral content, infiltration, and long-term water sustainability. Here's a breakdown. 1. Purity. Rainwater, generally purer when it first condenses and falls from the atmosphere. However, it can pick up airborne pollutants, e.g., sulfur dioxide, nitrogen oxides, particulate matter, making it slightly acidic, acid rain. When collected from surfaces like roofs, it can become contaminated with debris, bird droppings, and other pollutants. Groundwater, typically cleaner biologically, fewer pathogens, due to natural filtration as it moves through soil and rock layers. However, it may contain dissolved minerals, sometimes excessive, like arsenic, fluoride, or iron, and is more vulnerable to chemical contamination from agriculture, industry, or leaking tanks. 2. Mineral content. Rainwater. Low in minerals, often considered soft water. Lacks essential minerals like calcium or magnesium unless it picks up dust or other particles during collection. Groundwater. Rich in minerals, especially in areas with limestone or other soluble rock types. Often hard water, containing high levels of calcium and magnesium. 3. Infiltration. Rainwater. The primary source of recharge for both surface water and groundwater. Its infiltration capacity depends on factors like soil type, vegetation, urban development, and rainfall intensity. Groundwater. Result of long-term infiltration of rainwater and surface water. Infiltration is slow, often taking months or years to reach aquifers, depending on soil rock permeability. 4. Contribution to long-term water sustainability. Rainwater. Short-term supply potential through rainwater harvesting systems. DTUM. Useful for decentralized water management, reducing demand on municipal supplies. Groundwater. Critical for long-term water security, particularly in agriculture and areas without surface water. Over-extraction is a major concern. Recharge is slower than extraction in many areas, threatening sustainability. Feature rainwater, groundwater purity cleaner, initially but variable filtered, fewer pathogens, but risk of chemical contamination. Mineral content low, soft water, high, hard water. Infiltration, source of recharge. Result of infiltration, sustainability. Good for short-term use, crucial for long-term supply, but vulnerable to overuse. Conclusion: both are essential in the water cycle, but sustainable water management depends on using rainwater for non-potable or supplementary uses, while preserving groundwater for critical long-term needs. Your concern is deeply insightful and highly relevant to the karst hydrology of the Texas Hill Country, especially near the Balcones Fault Zone, where the interplay between flash flooding, limestone dissolution, and geological instability, like sinkholes or subsidence, is critical. Here's a comprehensive breakdown of what can be done to capture flash floods without accelerating karst dissolution or risking catastrophic collapse. 1 is the loneliest number that you will ever know. Yes, it's the loneliest number you'll ever know. 2 can be as bad as 1, but the loneliest number is the number 1. The problem: flash flooding plus karst risk. In karst terrains, water moves quickly through fractures, sinkholes, and caves, often bypassing filtration and carrying acidic or high carbonate rainwater into soluble limestone, DTUM. This accelerates dissolution, enlarges subsurface voids, and increases the risk of sinkholes, especially near fault lines like the Balcones. Flash floods, due to their force and volume, can magnify this risk by 2. Strategy: capture, delay, and redirect without deep infiltration. 1. Surface retention with lined basins. Use clay-lined or geomembrane-lined retention basins to hold stormwater temporarily without allowing it to percolate directly into the limestone. This detains water and slows runoff without feeding it into karst conduits. Gradual release can be controlled toward evapotranspiration zones or constructed wetlands. 2. Engineered wetlands and vegetated swales. Build shallow vegetated swales that absorb some water into the soil root zone, rather than allowing deep infiltration. Plant deep-rooted native grasses and shrubs that draw water upwards and stabilize soil. Cisterns and modular capture tanks. Install above-ground or buried cistern systems that directly harvest floodwater from arroyos or flash channels. Use for non-potable reuse, irrigation, fire control, etc., reducing runoff and demand on groundwater. 4. Controlled discharge to surface streams. Divert excess stormwater to existing surface water channels, like creeks or ephemeral streams.
Let me take you back to the wilds of early Texas, where one man's passion for plants would earn him the prestigious title, Father of Texas Botany. This is the story of Ferdinand Lindheimer, a botanical pioneer whose careful observations would help shape our understanding of Texas's diverse natural landscape. Picture yourself in mid-1800s Texas, where Lindheimer walked through untamed territories, meticulously documenting every plant species he encountered. His detailed letters to fellow botanist George Goldman paint a vivid picture of a land still lying undiscovered by Western science. In one particularly fascinating letter from February 1846, Lindheimer shared his observations about the cedar trees of Texas. He wrote, "The cedars start blooming in mid-January," describing how these trees vary dramatically across the state. He noted that while the coastal cedars of Lower Texas stood majestically at around 100 feet tall with trunks up to 1.5 feet wide, their mountain cousins were more modest, reaching only 40 feet with low-hanging branches. But Lindheimer wasn't just an observer, he was a problem solver. He noticed the scarcity of bees in central Texas was affecting fruit production. He didn't just document the issue. Instead, he took action, working with Wilhelm Bruckish to introduce Italian black bees to the region. This initiative would prove crucial in improving fruit tree pollination and agricultural success in the area. What's particularly remarkable about Lindheimer's work was his attention to detail. He didn't just collect specimens, he studied their habitats, their behaviors, and their relationships with other species. His comprehensive understanding of Texas flora was unprecedented for his time, and his collections would later become invaluable to botanical science. Through his letters and field notes, we get a glimpse of Texas as it once was, a wild, diverse landscape teeming with undiscovered plant species. Lindheimer's legacy reminds us that sometimes the most important scientific contributions come not from laboratories or universities, but from careful observers who are willing to venture into the wilderness, document what they see, and share their findings with the world. His work didn't just catalog plants, it helped lay the foundation for our understanding of Texas's rich botanical heritage, an understanding that continues to inform conservation efforts and botanical research to this day.
Let me take you back to the wilds of early Texas, where one man's passion for plants would earn him the prestigious title, Father of Texas Botany. This is the story of Ferdinand Lindheimer, a botanical pioneer whose careful observations would help shape our understanding of Texas's diverse natural landscape. Picture yourself in mid-1800s Texas, where Lindheimer walked through untamed territories, meticulously documenting every plant species he encountered. His detailed letters to fellow botanist George Engelmann paint a vivid picture of a land still raw and undiscovered by Western science. In one particularly fascinating letter from February 1846, Lindheimer shared his observations about the cedar trees of Texas. He wrote, "The cedars start blooming in mid-January. describing how these trees varied dramatically across the state. He noted that while the coastal cedars of lower Texas stood majestically at around 100 feet tall, with trunks up to 1.5 feet wide, their mountain cousins were more modest, reaching only 40 feet with low-hanging branches. But Lindheimer wasn't just an observer, he was a problem solver. When he noticed the scarcity of bees in central Texas was affecting fruit production, he didn't just document the issue. Instead, he took action, working with Wilhelm Brückisch to introduce Italian black bees to the region. This initiative would prove crucial in improving fruit tree pollination and agricultural success in the area. What's particularly remarkable about Lindheimer's work was his attention to detail. He didn't just collect specimens, he studied their habitats, their behaviors, and their relationships with other species. His comprehensive understanding of Texas flora was unprecedented for his time, and his collections would later become invaluable to botanical science. Through his letters and field notes, we get a glimpse of Texas as it once was, a wild, diverse landscape teeming with undiscovered plant species. While many of his original diary entries remain difficult to access today, his correspondence with Engelmann, preserved in A Life Among the Texas Flora, offers us a window into his fascinating world. Lindheimer's legacy reminds us that sometimes the most important scientific contributions come not from laboratories or universities, but from careful observers who are willing to venture into the wilderness, document what they see, and share their findings with the world. His work didn't just catalog plants, it helped lay the foundation for our understanding of Texas's rich botanical heritage, an understanding that continues to inform conservation efforts and botanical research to this day. Managing land in the Texas Hill Country presents both challenges and opportunities due to its unique topography, thin soils, and variable rainfall. To improve water retention, biodiversity, and long-term sustainability, here are some of the best land management practices. 1. Water retention. Rainwater harvesting. Capture rain from rooftops and hard surfaces using cisterns and tanks to reduce runoff and provide water for dry periods. Contour terracing. Swales. Construct swales or small terraces on contour to slow spread and sink water into the soil. Check dams, rock berms. Place small permeable dams in gullies or erosion-prone areas to slow runoff and promote infiltration. Soil mulching and cover cropping. Maintain mulch or plant cover on the soil to reduce evaporation and improve water holding capacity. Managed grazing. Rotate livestock to allow grasslands to recover, promoting deeper root systems that increase water infiltration. 2. Biodiversity enhancement. Native plant restoration. Plant native grasses, wildflowers, and shrubs adapted to the hill country's climate and soil. These support local pollinators and wildlife. Juniper management. Selectively thin ash juniper, commonly called cedar, to reduce water competition while retaining trees for wildlife habitat. Riparian buffer zones. Protect creek and stream banks with native vegetation to stabilize soil, filter runoff, and provide habitat corridors. Wildlife habitat creation. Install brush piles, bird boxes, and small water features to encourage a variety of animal species. 3. Long-term sustainability. Soil health monitoring. Regularly test soil and apply compost, organic matter, or biochar to build soil structure and fertility. Integrated pest management, IPM. Use ecological approaches to manage pests rather than relying solely on chemicals. Conservation easements. Consider placing part of the property under a conservation easement to preserve open space. Imagine standing in the heart of Texas. Beneath your feet lies one of nature's most remarkable underground treasures, the Edwards Aquifer. You might not see it, but this vast network of water-filled caves and rocks has been silently serving millions of people for generations. Let me tell you a story about this incredible water source. Back in the 1800s, when settlers first discovered these natural springs, they probably didn't realize they'd stumbled upon what would become the lifeblood of South Central Texas. The Edwards Aquifer isn't just any ordinary underground water system. It's one of the most productive aquifers in the entire United States, providing water to over 2 million people. But here's where our story takes a concerning turn. Imagine having a massive savings account, but instead of making deposits, you're only making withdrawals. That's exactly what's happening to the Edwards Aquifer. Every year, we pump billions of gallons of water from this underground reservoir. Cities are growing, industries are expanding, and agricultural demands are increasing. We're drawing water faster than nature can replenish it. The consequences? They're already becoming visible. Springs that once flowed abundantly are showing signs of weakness. Some have even stopped flowing completely during drought periods. It's like watching a mighty river slowly turn into a trickling stream. Think about this. What happens when we finally pump this ancient water source dry? It's not just about losing water, it's about losing an entire ecosystem. The aquifer supports unique species found nowhere else on Earth. It's about communities that have built their entire existence around this water source. It's about the future of millions of people who depend on it daily. But here's the thing, it doesn't have to end this way. We're at a crucial point where our actions today will determine whether future generations will have access to this precious resource. Conservation efforts, smart water usage, and sustainable practices can help preserve this natural wonder. The Edwards Aquifer has been here for millions of years. The question is, will we be the generation that sees its end? Or will we be the ones who ensure its survival for centuries to come? The choice and the responsibility is ours.
Use less water, use it wisely, try to capture rainwater, and try to allow water to soak into the aquifer and not just run off. See ya.
Today, let's explore effective land management practices in Texas's unique karst landscape, specifically focusing on protecting our precious water resources and preventing erosion. I'll share with you a practical approach that's been successfully implemented in the Texas Hill Country. Let's use a real example from New Braunfels to understand this better. Imagine a property with steep wooded slopes near spring-fed features, a typical scenario in the Hill Country. To manage such land effectively, we need to think about it in 3 distinct zones. Starting at the top, in Zone 1, the ridge and upper slopes, we have a crucial first line of defense. Here's what's fascinating. The existing woodland canopy acts like a natural umbrella. Those majestic oaks, junipers, and cedar elms aren't just beautiful. They're our frontline warriors against erosion. They catch rainfall before it hits the ground, allowing it to drip down slowly rather than rushing downhill. Now here's something many landowners don't realize. While juniper trees are native, too many of them can be problematic. That's why we practice selective juniper thinning. By carefully removing some ashy junipers, we create space for native understory plants to thrive, actually improving water recharge into the karst system. Moving down to Zone 2, the mid-slope terraces, this is where the magic of micro-terracing comes in. Think of it as creating nature's own staircases. We install small check dams that slow down water flow, giving it time to seep into the ground. Here's where we also introduce deep-rooted native grasses like switchgrass and little bluestem. These remarkable plants can send roots down several feet, creating natural highways for water to penetrate the soil. Finally, in Zone 3, our spring areas and drainage bottoms, we establish what we call riparian buffers. These are special no-mow zones where we let native species like sycamore and black willow flourish. These areas are critical. They're the last line of defense before water enters our aquifer system. We use clever techniques like live staking, where we plant willow or buttonbush cuttings directly into eroding banks, creating living walls that strengthen over time. This comprehensive approach isn't just about preventing erosion. It's about working with nature to create resilient landscapes that protect our water resources for generations to come. By implementing these practices, we're not just managing land. We're preserving Texas's natural heritage and ensuring sustainable water resources for our future. Welcome to a journey through time as we explore the fascinating history of Teawa School, a cornerstone of education in Oklahoma that has shaped countless lives over the generations. Picture this. In the early days when Oklahoma was still finding its footing, a small community came together with a shared vision to build a place of learning for their children. The first Teawa School was humble in size but mighty in spirit, serving as both an educational institution and a gathering place for the growing community. Those early years were marked by dedication and perseverance. Teachers would often travel long distances by horse and buggy to reach the school, sometimes staying with local families during the week. Students, too, would walk miles through all kinds of weather, carrying their lunch pails and determination to learn. As the decades rolled by, the school underwent significant changes, eventually becoming part of what we now know as Eustis Teawa Public Schools. This transition marked a new chapter in the school's story, bringing modern educational standards while maintaining the close-knit community feel that had always been its hallmark. One of the most intriguing aspects of Tiawa School's history lies in its historical records. These precious documents, some yellowed with age, tell stories of graduation ceremonies, school plays, and sporting events that brought the community together. Old photographs show children lined up on the front steps, their faces bright with promise, while attendance records and grade books offer glimpses into daily life from years past. For history enthusiasts and researchers, these archives are a treasure trove. They don't just tell the story of a school, they tell the story of a community, of changing educational practices, and of American rural life itself. Former students have shared memories of one-room classrooms, pot-bellied stoves that kept them warm in winter, and friendships that lasted lifetimes. The story of Tiawa School is more than just dates and facts. It's a living history that continues to evolve. Each generation adds its own chapter to this ongoing narrative, building upon the foundation laid by those early pioneers of education. Today, while much has changed since those first classes were held, the core values remain the same: a commitment to learning, a strong sense of community, and the belief that education can transform lives. The halls that once echoed with the footsteps of students in the early 1900s still serve as pathways to knowledge and opportunity for today's young learners. Whether you're a former student, a local historian, or simply someone interested in educational heritage, the story of Tiawa School offers a fascinating window into how rural education has evolved in Oklahoma. It stands as a testament to the enduring value of community-based education and the power of preserving our shared history for future generations to learn from and appreciate. Hey there. Let me take you on a journey to Tiawa, Oklahoma, a small, unincorporated community with a fascinating story that's deeply woven into America's heartland. You know, sometimes the smallest places hold the most interesting histories. Picture yourself back in the 1830s when members of the Cherokee Nation first settled this land, following the tragic Trail of Tears. This wasn't just any piece of land, it was part of the Cherokee Nation in Indian Territory, where they built new lives, established schools, and created thriving communities from the ground up. But the story of Tiawa as we know it really picked up steam, quite literally, with the arrival of the St. Louis and San Francisco Railway, or Frisco, as folks called it, in the late 1800s. Imagine the excitement when the railway station was built, becoming a bustling stop between the larger towns of Claremore and Chouteau. The whistle of steam engines and the clatter of train wheels became the heartbeat of this growing community. Here's something interesting. The name Tiawa itself holds a bit of mystery. It's believed to come from a Cherokee word, though people still debate its exact meaning. Some say it means peace, while others think it might have been named after someone. I love how these linguistic puzzles give us glimpses into the past. 1903 was a big year for Tiawa. That's when they got their post office. Now, this might not sound like much today, but back then, getting a post office was like getting your community's official seal of approval. It became a hub for local farmers and ranchers, a place where people would gather to collect mail, share news, and connect with neighbors. But here's where the story takes an interesting turn. When Oklahoma became a state in 1907, things started changing for small railroad towns like Tiawa. As automobiles became more popular and roads started crisscrossing the country, the importance of railway stops began to fade. It's like watching the tide slowly shift. The very thing that brought life to Tiawa began to matter less and less. Yet there's something remarkable about Tiawa's resilience. While it never grew into a big town, it represents something special, a living connection to multiple chapters of American history, from Native American heritage to the railroad era and beyond. It's a reminder that even the smallest dots on a map can tell us powerful stories about who we are and where we've come from. Today, Tiawa stands as a quiet testament to this rich history, preserving memories of a time when railways were lifelines and small communities were the backbone of America. It's a place where the past isn't just remembered. It's still very much alive in the landscape and the stories passed down through generations. Picture this: an endless sea of swaying grass stretching as far as the eye can see, dancing in the wind like waves on an ocean of green and gold. Welcome to the prairie, one of nature's most magnificent yet often overlooked landscapes. You might think prairies are just empty grasslands, but let me take you on a journey that will forever change how you see these remarkable ecosystems. These vast expanses have been the stage for some of North America's most dramatic stories. From the thundering hooves of millions of bison to the hardy pioneers who first crossed them in wooden wagons. Beneath the surface, prairies are absolutely teeming with life. Their soil is among the richest on Earth, built up over thousands of years by the constant cycle of growth and decay. The roots of prairie grasses can extend up to 15 feet deep. Imagine that, an underground forest of roots keeping the soil in place and storing massive amounts of carbon. But here's something that might surprise you. Prairies need fire to survive. Yes, you heard that right. Natural fires, usually sparked by lightning, are essential to prevent trees from taking over and to recycle nutrients back into the soil. It's nature's way of pressing the reset button, and prairie plants have evolved to not just survive these fires, but to thrive because of them. The prairie is also home to an incredible cast of characters. Meadowlarks fill the morning air with their flute-like songs, while prairie dogs create vast underground cities that can span hundreds of acres. Monarch butterflies depend on prairie plants during their epic migrations, and countless species of wildflowers paint the landscape in vibrant colors throughout the growing season. Sadly, these magnificent ecosystems are among the most endangered in North America. Of the original tallgrass prairies that once covered vast portions of the continent, less than 1% remains. But there's hope. Conservation efforts are underway to protect and restore these vital landscapes. Next time you're driving through the heartland and see what might look like just grass, remember, you're looking at one of Earth's most complex and important ecosystems, a place where every blade of grass tells a story of survival, adaptation, and resilience. The prairie isn't empty at all. It's full of life, history, and endless possibilities for the future.
This is a cool rainstorm. There's some pretty incredible rainfall going on right now. The rain is very cool, I will show.
Let's see what we can find here. Oh, it looks like a caliche pit. How strange that there's just a random hole out in this